This is 658 in college algebra. Today we're talking about rational functions. Tests will ask you a lot of questions about it. Is this a polynomial function? Is it a rational function? Or is it neither? A rational function has to be a polynomial over a polynomial. First of all, what's a polynomial function then? All the variables, exponents, are positive integers or zero. That's 1, 2, 3, 4. You can't have like the 1/2 power, like square roots, cube roots. Those are not polynomials. We'll talk more about that later. A rational function got a polynomial over a polynomial, meaning you got x's in the denominator, which is bad. This is not a polynomial function at all. It's a rational function. You will get all kinds of asymptotes to come into this situation. 3 kinds: vertical asymptotes, horizontal asymptotes, and oblique asymptotes, which is probably new to most of you when you've had FST already. So, how do you find vertical asymptotes? Vertical asymptotes are the easiest ones. They are the values of x that makes the denominator 0, right? So, vertical asymptotes are down and out. Horizontal asymptotes, there's 3 different situations that have to look for. They are probably the most complicated of them all. First of all, there will be no horizontal asymptotes if the degree of a of x, notice where I have you see is the numerator or in the denominator. So if the degree of the numerator is bigger than the degree of the denominator, there's no horizontal asymptotes. We'll go through these one little thing at a time, but just kind of explain it. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote will be at y equals 0. And if the degrees are equal to each other, then you've got to take the leading coefficient and divide them and write them as a fraction, and that's where it'll be. So complicated, we'll come back to it later. If there's an oblique asymptote, the degree of the numerator is just 1 more than the degree of the denominator. So what you have to do then, you have to do synthetic division. Actually, you have to do long division, but we've made it nice to where the denominator will always be a linear situation. That's the only time you can use synthetic division, is when that polynomial is linear, like x plus 1 or something. It's not quadratic, it's not cubic. If it was quadratic or cubic, you have to do long division, which is up, down. That's for FST people to do. We're just plain on college algebra. So let's go through each one right here and find vertical asymptotes, horizontal asymptotes, and oblique asymptotes. It can't have all of them at the same time. It is impossible. If something has a horizontal asymptote, it won't have an oblique asymptote, or vice versa. If it has an oblique asymptote, it cannot have a horizontal asymptote. So, one at a time. They want to know if there's any vertical asymptotes. First, we look at that and see if it can factor or anything like that. Just linear over linear. We want to know what value of x would make the denominator 0. What could x be? If x is -1, so there's our vertical asymptote. At x equals -1. It would be a vertical line, x equals -1. And that's it. Horizontal asymptote. We'll use this sheet to our strongest. I still haven't decided how it's going to go, if I will give you this for the test or not. You know, I haven't made up my mind yet, so prepare like I'm not going to give it to you. Horizontal asymptote. We got to look at degrees. Tell me about the degrees of the numerator versus the denominator. Is the numerator bigger? Is the denominator bigger? Or are they the same degree? What's going on? Same degree. This is the first power. This is the first power. So that fits into this situation. The degrees are equal. Cool? It says your horizontal asymptote will be at y equals the leading coefficient of your numerator divided by the leading coefficient of your denominator. What's the leading coefficient of this bad boy right here? 1. Leading coefficient of this bad boy is 1. So your horizontal asymptote will be at y equals 1 over 1, which we just plain old call that 1. Cool? And then for oblique asymptotes, they want to know if the degree of the numerator is 1 more than the degree of the denominator. It's not, right? The degree of the numerator is not 1 more, so that means that there are none in this situation. And again, these two are kind of like partners right here. If you have a horizontal asymptote, then you cannot have an oblique asymptote, or vice versa. If you do not have a horizontal asymptote, you may or may not have an oblique asymptote. So let's do it again. Vertical asymptote. That's where they want to know where this equals 0. Well, it would be much easier to refactor that quadratic. Since the a value is 1, if we could write him in factored form, that'd be awesome. Could you find two numbers that multiply together to be -10? And that together to be 3. Tell me about the sign of the two numbers. If that's multiplied, it'll be negative 10. Both positive, both negative, and one negative. So we're looking at maybe 2 and 5. And if one of those was negative, don't those add together to be 3. So this factors to be x minus 2 times x plus 5. These are the same thing, right? This guy and this guy, same concept. What's so great about the green guy? We can figure out where the denominator is 0. It would be at x equals 2 and at x equals negative 5. There's 2 vertical asymptotes of that situation. One of them at x equals negative x equals 2, and one of them at x equals 5. So negative 2. Horizontal asymptote, that's where you got to go through the list. You got to check your degrees out. What's the degree of the numerator? It's 0. What's the degree of the denominator? It's 2. So the denominator's degree is bigger than the numerator's degree. That's where the denominator's degree is bigger, or vice versa. The numerator is smaller than this. Where will the horizontal asymptote be at? Y equals 0. Because the numerator is less than the denominator when it comes to degree-wise, that will have a horizontal asymptote of y equals 0, which means if we had a horizontal asymptote, that it's not possible for us to have an oblique asymptote. What we did not do to either of these was graph them. The beauty of having the graphic calculator is not only will we figure all of this stuff out, we will also graph it, and the graphing calculator kind of checks our work for us, but yep, I see those asymptotes now. So first, let's fill all this information out. Vertical asymptote is what values of x make the denominator 0. This is just plain old linear, right? There's no need to factor in what value of x makes him 0. X equals 2. So when we graph this, we'll see something weird happen at that x equals 2. It'll be an asymptote. Horizontal asymptotes, you got to check all 3 cases. Let's look at the degree. If you like to write them off to the side, that might help you. This has degree 2 in the numerator, correct? And what's the degree of the denominator? Degree 1. The numerator's degree is greater than the denominator's degree. So, if the numerator's degree is greater than the denominator's degree, right, what does that say? That we will have no horizontal asymptote. All right with that so far? Then, do we have an oblique asymptote? Is the degree of the numerator, a of x, is the numerator, one more than the degree of the denominator? Is that happening? So, yes, we do have one. Now, how do you start? You have to do synthetic degree. We need to synthetically divide this denominator by that numerator. So, if you've got to synthetically divide by the polynomial of x minus 2, what is the value that makes that 0? You will synthetically divide by 2. What do you synthetically divide? The numerator, which is x squared. We need to write all of the stuff though. There is 1x squared for a coefficient. There are no x's, and there are no constants. Remember, if that's a second degree polynomial, there better be 3 ingredients in there where you synthetically divide. So now you start doing synthetic division. 1 comes down, multiply, 2 comes down, multiply, you get a 4 over here, and you get a remainder of 4. The rule says, ignore the remainder. Nobody gives a crap about your remainder. Your oblique asymptote is right here. You just need to translate that. It was a second degree in the first place. Won't this now be a first degree? So this is really where your x's are at, and these are your constants. Your oblique asymptote will be at y equals x plus 2. 1x plus 2. Right? You've got 1x plus 2. Rock and roll? And like I said, we'll do more of those. It's just weird at first. So, we had a vertical asymptote, we had no horizontal asymptote, and we did have an oblique asymptote. Before we graph it, they want us to figure out where the x-intercept and the y-intercept is also. So, x-intercept is when y equals 0. So, this is basically y. If I let that equal 0, we have this. Watch this. And that's what you have. You let y equal 0. Then, you multiply, you get rid of this x minus 2 down here, and you multiply both sides by x minus 2. And when you do that, that would go away, and you take 0 times x minus 2. What 0 times x minus 2 turn out to be? 0. So, you now have this. 0 equals x squared. all that you have to do in a rational function to find your x-intercept, make a note of this, is where is the numerator 0? Right. Numerator equals 0. Because you're letting y equal 0, and then you want to solve for x, you get rid of this crappy denominator by multiplying both sides by it, and 0 times that denominator will just go away. You want to know where the numerator equals 0. So, you've got 0 equals the numerator. What could x equal to make that true? Square root both sides. Square root of 0 is plus or minus 0, right? Which we just call what? 0. 0 is an x-intercept. To find the x-intercept, you let y equal 0. So how do you find the y-intercept? Let x equal 0. So let me kind of get rid of this. Let me get rid of this. Like I want to right. To find the y-intercept, you let x equal 0. So this would be, this is gone. This is gone. You have 0 over negative 2. Right? You put 0 in for x, which is 0 squared, turn out to be 0. Then you get 0 minus 2, which is negative 2. What does 0 over negative 2 turn out to be? Y-intercept also at 0. So you let x equal 0. Or no. Again, I know this is a lot of information. That's why we got 6 more of these to do, or 5 more of these to do. We'll get better. Let's graph it. Then we'll do the domain after that. Okay? So, let's punch this puppy in our graphic calculator. And quite honestly, that might be the hardest part for you, because you have to use parentheses. Your entire numerator should be in parentheses, and your entire denominator should be in parentheses. So, just a safe idea to do that, x squared is the numerator divided by x minus 2. It's got to be in parentheses so it stays in the right place. Then let's just zoom 6 in and see what it looks like. And you see some funny stuff happen. First of all, there's a vertical asymptote at x equals 2. Right? If you kind of just pretend for a second, some of your calculators might show you that thing, some of them might not. You know there might be a little line there. There is also an oblique asymptote. You see this thing right here? That oblique asymptote is right there, which that's new to a lot of us. So what I don't like is I don't see a lot of this branch right here. So my standard window is probably not good enough. I'm going to change my window to be y-max of 15. In most of them, the standard window will work on your homework, but now you can see that you can see more of that branch right there. So, let's do this. Let's make our graphing calculator sketch. I've got some grid marks in there to help you make this a little more accurate. So, I'm going to put my scale not quite centered, because remember I went a little higher on that y-axis scale. And I'm going to let each one of these count for 2s. So this is really 2, 4, 6, 8, 10, 12 right here. All right, that's really 12 instead of 15. 2, 4, 6, 8, 10. Negative 2, 4, 6, negative 8. And this is going to be negative 10 right there. It might actually help you out. When I did my answer key, it helped me out to actually put all of this in there to make like a much 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. I'm not going to require that. You do have to have your window parameters on there, but we're going to make a really, 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 really accurate graph for you. So might as well put them if you want to be really, really accurate. Cool? Then asymptotes first is what I like to do. I've got a vertical asymptote. It's always a dash situation when you draw asymptotes. Vertical asymptote at x equals 2. Put that puppy in there, and I have the dash. Then underneath it, please write x equals 2. Right there. There is the vertical asymptote. You don't need to put VA. It's pretty obvious when you dash it, it's an asymptote. Just tell me the equation. There's also an oblique asymptote at x plus 2, so that's why we put the grid marks in there to make these more accurate. I'm going to literally graph that line. It's got a y-intercept of 2. Ooh. Correct. It's got a slope of 1, which 1 over 1, even though these are going by 2s, if I rise 2 and run 2, isn't that still 1 over 1? Right, so I could rise 2, run 2, rise 2, run 2. And honestly, it helps to just put all these points. There's not that many. I'm just speaking from when I made my key out. I didn't put them all, I just put a few and connected and it didn't look right. Just because it's not really square in the first place. It's more rectangular. It just doesn't look right if you don't put them all. Then grab your ruler again, put dashed line. Right there. That's your oblique asymptote. Put y equals x plus 3 out there. At one of the ends. So far so good. I'm a highlighter person. I don't know about you. I took a pink highlighter and highlighted my asymptote. You know, that's up to you if you want to do that or not. I can pass them out if you like that. Then I put my real graph. I go back to my graphing calculator and I can see where those branches are. Right? So I know they're going to be in this type of region. But I want to plot all my intercepts and all that stuff first. X-intercept is 0, so right there. And the y-intercept is 0. So isn't that really the point of 0, 0? Maybe 0. That's 0, 0. Cool. And then that gives me a point in this branch. It's going to follow this asymptote and then curve around. And how did I know that? I looked at my graphing calculator and saw it follow that asymptote and then curve around a little bit. It is also kind of nice to find at least one point of reference up here on this other branch since I don't have any points of reference. So how would I do it? I go to my table of values and just look. Like the x values are bigger than 2 in that, so I'm looking, hey, 3, 9, that's a pretty nice little place, or 4, 8, that's all. 4, 8 wouldn't work, oh yeah, 4, 8 would work, so I'll plot 4, 8, and then realize that's where we will get so much better at these by the end of the worksheet. That was just the first real graph example, but we're not quite done. We still have to list the domain. I just wanted you to see the graph to understand the domain. The domain is always about x. All you really have to focus on is your asymptotes, because that's what x can be. Like the domain starts with from negative infinity to positive infinity. You can't have x equal 2 because there's a vertical asymptote. So if you were looking from left to right, wouldn't it go from negative infinity all the way up to 2? 2 doesn't count, then you start over again, union 2 to infinity. The numbers that will be critical in your domain are all about your x, your vertical asymptotes, whatever x can't be. So, I, again, told you the colors I highlighted the asymptotes a color, and then I highlighted the branches a different color. You don't have to do that if you don't want to. It's just up to you. Woo! Let's do another one. Same one, right? So, whatever. Let's not have 4. Woo! Let's try again. Rational function. Let's find vertical asymptotes. We want to know when the denominator is 0. So, we better take that quadratic and see if we can factor it. So, A is 1. Two numbers that multiply together to be 5 and add together to be 6. 5 and 1. So you like to write this off to the side, you get x plus 1 times x plus 5. It's up there, x plus 1. I should rearrange these because now we have a real interesting situation. Do you see an x plus 1 upstairs and an x plus 1 downstairs? This will create what's called a hole. First of all, this is what really happens, is they get to cancel each other out. So if we resimplify this to 1 over x plus 5, is what that graph really is. But the reason why we need these is to realize that negative 1 is a bad number. Doesn't negative 1 make this guy turn out to be 0 in this situation? So there is no asymptote when you've got the same thing over itself. You got x plus 1 over x plus 1. There is not an asymptote there. You have to tell me that there's a hole in the graph at what value of x makes that 0? Negative 1. Right? And then what you have to do is you have to find the y value of that by putting negative 1 in for x, but you don't want to put it into this math, you want to put it into that math. If you put negative 1 in for x, wouldn't you get 1 over negative 1 plus 5? How much? So 1 over 4 is the y value of that. When you get the same quantity upstairs and downstairs, we will have a hole in the graph. There will not be an asymptote there. This will give us an asymptote, though, where at x equals negative 5. So we will have a vertical asymptote at x equals negative 5, and we will have a hole in the graph at negative 1. Then we have to substitute in and find the y value. As an ordered pair, there will be a hole there. Woo! Horizontal asymptote. Let's go through all three ways. What's the degree of my numerator? It's 1. What's the degree of my denominator? It's 2. Y'all cool with that? Degree of the numerator greater than the degree of the denominator? No. Degree of the numerator less than the degree of the denominator? Yes. Isn't that happening? So where's my asymptote at? Y. Is everyone okay with where I'm getting from? If there's a horizontal asymptote, can there be a vertical, or excuse me, an oblique asymptote? Not happening. X-intercept. That's where the numerator equals 0. Because we let y equal 0, that cancels out. We want to know where the numerator equals 0. Where does that numerator equal 0? X is negative 1. X is negative 1. There's an x-intercept there. Can that happen? Can that happen? When x is negative 1, isn't there a hole in the graph? So what you really have to do is look at this guy to find your x-intercept and y-intercept. Like, hey, can't look at him because, I got a hole in the graph there. Where, oh where, would this equal 0 at? When it's 1. When does that equal 0? When does 1 equal 0? Never. Right? So are there any x-intercepts? There's none. That thing really does not cross the x-axis at negative 1 because there's a hole in the graph right there. Y-intercept, that is where you look at this guy right here. Again, look at this guy. Let x equal 0. So you get 1 over 0 plus 5. Plus 1 over 0 plus 5. 1. Cool? Let's see if we can do our domaining without a graph. Work from smallest to largest. These are the x values that are bad for us. Those are the x values that are bad for us. Bad for us, correct? So let's start from negative infinity. Who's our first bad number we come across if we go from smallest to largest? Negative 5 or negative 1? Negative 5. You'll never count. Then you got a union again, and you start over at negative 5 again. Right? You just start over there again. Then you go to the next bad number. The next bad number is negative 1. Cool? Then you've got to end up with infinity going on somewhere. So you union again, you have to start over from negative 1 to infinity. Bad numbers, negative 5 and negative 1. Everything else should count. Let's graph. Gotta use an array. We'll put the whole numerator. Graph the original dude now. This is what you're typing into your calculator. Not this. Right? You want to see this. Because then you get your asymptote and the holes and all that stuff. So graph the original guy and put everything in parentheses. You got x plus 1 in the numerator in parentheses divided by x squared plus 6x plus 5 in parentheses. Then zoom to. And we should see what we figured out. You don't see much of anything. You see, and that thing tails off. And let's graph what we say. First, we zoomed 6 and we saw everything we wanted to, so put your axis dead center. Here. Here. Pens all around. I'm going to go ahead and put 2, 4, 6, 8. You don't have to do this part if you don't want to. It's up to you. I've got a vertical asymptote at x equals -5. So I'll have my dash liner and go to x equals -5. Split the distance. That's why I like to put those numbers. It really helps me see what x equals -5 is at. Again, that's really and you've got a horizontal asymptote at y equals 0. That's the x-axis. You don't have to put that if you don't want to, because it will be right over the top of the line that you just grabbed right there, so it's something that you'll just have to see when you make your sketch. There's a horizontal asymptote at y equals 0. That's the x-axis. Let's check out our picture again, see where those branches are. Right, there's going to be a branch down somewhere. There's going to be a branch up here somewhere. So we know where our branches are going to be. There's one other point you should graph first. Was there anyone funny in this situation? Graph the whole at -1, 1/4. So let's go to -1, 1/4 right there and put a hole. There's no production. That's what it is. -1, 1/4. Cool. Did we have any y-intercepts? 1/5. So that's at 1/5, 0, we like right here. Sorry, minus 1/5, 0, right here. 0, 1/5, 0, 90. Cool. Now I can complete this branch up here because I know it's going to approach that asymptote. It's going to come through this hole, but do not go inside of it. And there's also a horizontal asymptote at y equals 0, so it'll get closer and closer and closer to that thing. How did I know that again? I looked at my graphing calculator to see that. Only thing I plotted was these two specific points right there. Over here, it's going to be like so. And it approach the horizontal asymptote and the vertical asymptote. Cool? I don't even care if you find a point on there or not, to be quite honest. I care that you plot all of this information. Nice? Next, I know that you don't see these rules up there anymore, but I've got them in front of you to help us. First, there should be like an f of x equals or something, that's a typo. Let's see if we can factor this stuff a little bit. Numerator, 3x squared minus 2. First of all, there's only two terms. Is there a GCF you can pull out of that puppy? 3x squared minus 2? Nope. Not a difference of squares. Can't factor. 3x squared. Denominator, x squared plus x minus 12. A value is 1. Then you find two numbers that multiply together to be -12 and add together to be +1. -3 and +4. Alright? So x minus 3, x plus 4. Sweet. Vertical asymptote, where the denominator equals 0. No hole in this situation because I didn't get an x minus 3 upstairs and downstairs. I didn't get an x plus 4 upstairs and downstairs. There are no holes. There are just two vertical asymptotes. One of them at x equals 3, the other one at x equals -4. Cool? Horizontal asymptote. Let's do the list. Degree of my numerator is 2. Degree of my denominator is 2. Those are the same. That's where this comes in. The degrees are the same. Cool? Degree of 2, degree of 2. Just take your leading coefficients and write them as a fraction. Who's the leading coefficient of this guy, of the numerator? 3 over 1. So it will be at y equals 3 over 1, which we just usually call 3. Nice? If there's a horizontal asymptote, will there be an oblique asymptote? Sweet. X-intercept is where the numerator equals 0. Fun stuff. 3x squared minus 2 should equal 0. Since there's only x squared, my job is x squared all by itself. Add 2 to both sides. Divide by 2. And then the fun part. Now we got a square root of 2/3. So, since the square root, you get x equals plus or minus square root of 2 over square root of 3. You're not allowed to have a radical in the denominator. So you get rid of that radical in the denominator by multiplying by the radical 3 over radical 3. That is x equals plus or minus. Radical 2 times radical 3 is radical 6. Radical 3 times radical 3 is 3. That's done. It is radical 9, which is 3. Cool? There's our two x intercepts. Square root of 6 over 3, negative square root of 6 over 3. You cannot reduce the radical with the whole number. You can't call that like radical 2 over 1. It doesn't work like that. That was awesome. Y-intercept, where x is 0. Cool? So check this out. If x is 0, that means this is going to go away. Because that would turn out to be 0. Right? That's going to go away. And that's going to go away. So you put 0 in for all of that stuff. Wouldn't you be left with negative 2 over negative 12, which reduces to what? 1 6. That's where your x intercept is. Because you let x equal 0, all the stuff with x's goes away, and you're left with constant over constant. So, domain, we got no holes, we got two bad numbers, from negative infinity to, be careful, a lot of people put 3 first, so you got to start with the smallest one, which is negative 4. And you start over again at negative 4. We've got another bad number at 3. Start over again at 3. Go 2 and 2. That's crap. Crap, yeah. Always go back and graph your original. You can do fix them also, they'll fit. You want to make sure you see everything that you just figured out. So we've got two vertical asymptotes. You can see the weird stuff happening here and here, right? And you've got that horizontal asymptote at whatever the heck we said it was, at 3. Alright, so let's graph all our asymptotes first, after we do our standard window grid, of course. Hands all around. And asymptote. Got a vertical one at x equals 3, so also had one at x equals negative 4. Had a horizontal asymptote at y equals 3. That's there. Then I go back to my calculator and I take a look. Like, okay, this is grid here. I got to have a branch up here, a branch there, and this branch here in the middle. But I got to use some of my other information. Sorry, I'm going too fast. I'll just catch up. So I look at my other information. I've got x-intercepts at these nasty places. I'm not going to literally write them down, but they're like right there. Negative square root of 6 over 3 and positive square root of 6 over 3. You could punch them into decimals, see what they were. They're really easy in there. And you've got this y-intercept at 1/10. That tells you something is hard to see from the calculator without zooming in, that this little branch right here crosses the x-axis twice and comes up and does that little number right there. So you need him to start there and then get closer and closer to that asymptote. Here. Then the other two branches look something like this. Again, calculator helps me see this. Good stuff right here, baby. Good stuff. Next one. I don't want to graph it. Let's just fill out this information, and then we'll graph the last. Okay? Something really weird happening here. So, let's fill out the information. Vertical asymptote. I don't need to factor the denominator. Here's the weird thing. Let's see if we can factor the numerator. Can you think of two numbers that multiply together to be a positive 3 and add together to be a negative 2? They have to multiply together to be a positive 3. So it's either going to be 1 and 3 or negative 1 and negative 3. Correct? Those are the multiples. Do they add together to be negative 2? Yes or no? No. So, you can't factor this. Okay, I can't factor it. So I'm going to leave it the way it is. I really didn't do anything to it. Vertical asymptote, I won't have any holes in this situation because I'll never get an x minus 1 over an x minus 1 because the top doesn't factor, right? I'll never get that to happen. I will get a vertical asymptote at x equals 1. Horizontal asymptote. Let's see. Degree of this guy is 2, correct? Degree of this guy is 1. That's where the degree is bigger. So degree bigger, the degree is the denominator, meaning I have none. With me? Then, will I have an oblique asymptote? Just because you say none here doesn't mean you'll have one. The degree of the numerator has to be exactly 1 more than the degree of the denominator, if that happens. So, I will have one. How do I find it? Synthetic division, just because this guy is bringing it. We can synthetically divide by what number? 1. Take this dude, there better be 3 guys in there. They're all represented. Their coefficient, synthetically divide, and forget about the remainder. Honestly, it really doesn't matter. The remainder doesn't matter. You translate this into a linear situation. This is x, and this is your constant. It would be at y equals x minus 1. Is where that oblique asymptote goes. X-intercept is when the numerator equals 0. You gotta find that, when the numerator equals 0. We already discussed it won't factor, but that means you can't find it. Can you figure out where x squared minus 2x plus 3 equals 0? That's possible too. You could either use the quadratic formula or complete the square on it. So, let's complete the square. Just watch me complete the square on it at the same time. Plus 3, well that's plus blank, equals negative 3 plus blank. Right? Help me fill in blank. 1. What kind of answers do we get, real or imaginary? Does that thing cross the x-axis? Well, that means that there are no. Right. You didn't get any real solutions, so there's no x-intercept. There's none. Y-intercept, you let all the x's equal 0, so peace out, peace out, peace out. All the x's equal 0, right? They went away. You're left with 3 over negative 1. So isn't there a y-intercept at negative 3? And then the domain, I think we're pretty good at that. There's only one bad number from negative infinity to 1, and 1 to the big 1 to that number. Then you grab it, and it's there. Cool? Next one. Fill out vertical asymptote, horizontal asymptote, and oblique asymptote. And then check backwards. Discuss factors. The numerator and the denominator is linear, so no deal. Question for you before I go any further. Will there be holes in this graph? Do you have the same quantity upstairs and downstairs? No holes. So x plus 2 is up, none down. X plus 5 is up, none down. X plus 1 is down, none up. Right? So no holes. Vertical asymptote at x equals 1. Horizontal asymptote, again, that's the hardest part, in my opinion, is I gotta remember all this stuff. I've already made up my mind. I will give you these boxes on the test. Okay? So, horizontal asymptote is the degree of this guy is 2, the degree of this guy is 1, the degree is bigger than the denominator, meaning that there is none. Cool. Oblique asymptote, will there be one? Is the degree of the numerator one more than the degree of the denominator? Yes. So how do you find it? You typically divide by -1. 1, 7, 1, 6. Don't care, right? Don't care about the remainder part. So where's my oblique asymptote? Y equals x plus 6. X-intercept. How do I know where those are at? Those are parts that I'm not going to provide for you. Like x-intercepts, you got to remember, where do you find x-intercepts? Numerator equals 0. Where's the numerator equal 0 at? Love that factor. -2 and -5. Correct? Y-intercept. That's when you let x equal 0. So bye-bye, bye-bye, bye-bye. Where's the y-intercept? N/1. Domain. Okay. No bad numbers. -1, the only bad number. Let's crack it. Let's check it out on the standard window. Don't forget parentheses. If your graph doesn't match the information that you just figured out, that's probably your mistake if you didn't put stuff in parentheses. It should have an oblique asymptote. It should have a vertical asymptote. And you see how I can't really see that branch up there where the are. So that means I want to change my y-max. What do you want to go up to? Might as well do an even amount since our scale on this little grid always goes by 2s, right? So let's go to 14. I know we normally go to 15, but now that we've got this cool little grid, let's see what that looks like. That's good enough, right? I see enough of that branch. So I want to get up to 14. So I'm going to just counter down. Let's see if that works. 12, 10, 8, 6, 4, 2, 0. Is that going to give me what I want? Can I get down to -10 also? So, can't go by 2. What if we went by 3 and went up to 15 instead? Would that be okay? What if you count by 4? I don't really care what you do, right? You know, if I count by increments that you can go by, so I'm going to go up to 15 now, go by 3. That tells me where I put my line. Basically do 15 on both sides. Well, top and bottom, I should say, not both sides. 3. Over here, I can still go by 2. Still 3. That will make our oblique asymptote a little challenging to graph, but it's still possible to do because our scale is not even. These are 2, these are 3, but my vertical asymptote always is steady. This is -1. The oblique asymptote is at y equals x plus 6, so you do know that you start at 6 on the y-axis. Then the slope is 1, so if I rise 1, I have to run 1 also. That's going to become a problem. What you could do is just figure out another 19 square here. Like, what if you put 2 in for 6 for x? What would y turn out to be? 8. Okay, I could graph 2 8s if I wanted to. What if I put 3 in for 6? For x, what would y turn out to be? So couldn't I graph 3 9? That's a better place to graph. And I just started making up. If I put 6 in for x, wouldn't y turn out to be a 12? And that's probably enough. I know it's not going to be the most accurate thing in the world, but we could at least try to connect them together. Get a good ballpark of where that is. What multiple did I put in for x? Multiple was 3. That's what my scale was on the other guy. So I just figured out I put 3 in, got 9, got 6 in, got 12. Two. Let's check my calculator out again, see what this thing's supposed to look like. So yeah, it looks like this. Go to my information about intercepts and plot them. I have x-intercept at -2, -2, and -5. So that's again where my accuracy kind of your oblique asymptote is like, hey, should that dot be on the asymptote? No, it should not. But it's going to be kind of close. Okay? Because it's an x-intercept of -5. Depends on how accurate you are on putting those dots together. Okay? Then, since that happens to 2 different guys, that means this has to happen to that puppy. You gotta go up, come back down. That little branch has to cross the x-axis twice, so it has to come up and come back down. I had a y-intercept of 10, so that's that now. And I know that that branch was probably better. Ballpark branches. And finally, one last. And boy, is it a problem. Quadratic over quadratic, we got to factor it. And it's not easily factorable because the a value is not 1. Wait a minute! Is there a GCF you could take out of those 3 terms before you get started? Wouldn't it be sweet if you could take out a 2, but we can't. So I'm going to go do some work off to the side. I'm going to kind of even label one of those. It depends on where you got room. This is my numerator. 2x squared. What are my 2 numbers that multiply together to be -12 and add together to be -1? 3 and 4, which one's negative? The 4. So my numerator is really 2x squared minus 4x plus 3x minus 6. I just took that dude, put it into the minus 4x plus 3x, factoring him, goes through. You all with me? 2x squared minus 4x plus 3x minus 6. Taking out 2x. What can you take out of the second group? 3. There you get x minus 2 back both times. And now I'm going to go, you can write it down again if you want to, but I'm going to put it right next to my numerator up here. It's really 2x plus 3 times x minus 2. That's my numerator. 2x plus 3 multiplied with x minus 2. Now I got to factor my denominator. Those multiply together to be 6. 6. 2 numbers that multiply together to be 6, add together to be 5, are 2 and 3. Alright? So this is going to be 2x squared plus 2x plus 3x plus 3. That's it. Factor 2x plus 3 minus x plus 1. Due to the fact that we got a 2x plus 3 on top and bottom, I will have a hole. That's where I go first. There's going to be a hole at. You just need to figure out what makes that 0. what would make 2x plus 3 turn out to be 0? Not negative 2/3, negative 3/2. Cool? Negative 3/2. Then how do I figure out the y value? It's time to say, clean up. These go away. They're like divide out to be 1, right? And you'd be left with x minus 2 over x plus 1. And your job is to put negative 3/2 in for this, which I would rather put negative 1.5 in for that instead, right? So grab the old calculator and get out of your graph and say I want negative 1.5 minus 2, which is negative 3.5, so I'm just going to jot that down. Negative 3.5 is what my numerator turned out to be, over negative 1.5 plus 1 is negative 0.5, correct? If you put negative 1.5 in for x, you get this. Punch that in, and what does that turn out to be? So you get 7 for that. Is that what you get? 7? So my whole is at negative 3/2, 7. Are there any other vertical asymptotes though? At x equals negative 1. 2? Horizontal asymptotes. You don't need this information because all of this stuff over here, there's a hole there, right? There won't be anything at the hole. There's a hole there. You read this guy. Horizontal asymptote. I'm sorry, I was thinking about interception line. That's my fault. Horizontal asymptote, we got to read this. Degree is 2. Degree is 2. Aren't they equal degrees? Right? Equal degree. So leading coefficients over each other, which would be what? Y equals 1. 2 over 2, which is 1. Right? Leading coefficient of 2. Leading coefficient of 2 lines up to be 1. Oblique asymptote can't be any. If you do a horizontal asymptote, there can't be an oblique asymptote. Now what I was talking about, your x-intercept is what I was thinking about. X-intercept is where you want to read this guy. Don't use the information where it was factored and you got holes. Right? There will be nothing there. There is a hole there. So the x-intercept is where y would equal 0. In the simplified version, that would be at 2. Right? Y-intercept, you go back to Mr. Original, and you let x equal 0. So all the stuff with the x's is gone. You got negative 6 over 3. Which is that? Negative 6. And then the domain, we have 2 bad numbers. We've got negative 1 for a bad number, and we've got negative 3/2 for a bad number. So negative infinity, which one's smaller? Negative 3/2 is negative 1.5, right? That's smaller than negative 1. And then you go to your next bad number. So you use them twice, you go to your next bad number, which is at negative 1. Then you use them again, and there are no more bad numbers, so you go up to infinity. Like crap, and easy to get done. Remember, use parentheses, type the original guy back in. Gotta be in parentheses. Go back to June 6. See what that looks like. Zoom 6 works just fine. So you find your axes. So let's get our axes in there. We did dead center of 10. The thing you got to be careful with is this guy's got a hole. You got to recognize him. Well, 10's all around. Put your axes first, then put your asymptote. I got a vertical asymptote at x equals negative 1. That would be right here. Go back here. I got a horizontal asymptote at y equals 1. then the next thing I would grab is my hole. Right? You put the asymptote, then go plot where that hole is at. It is at negative 1.5, basically, almost negative 2, step 2, 4, 6, 8, so right about, and labeling them, negative 3.5, yes. There's the hole in the graph. Any other x-intercept and y-intercept? I got an x-intercept of 2. Is that right? What did I do wrong? X-intercept. Yeah, okay, that's my thing. There's the hole on the wrong side. Got that negative 1. Oh, that's not a hole. There's the hole. Negative 3.5. 7. Sorry, thank you. X-intercept is 2. Y-intercept is negative 2. That means you got a branch down here. And then you got a branch right here. And then the hole there. All it does. There's nothing. Fun stuff.